Welcome, everyone, to this explainer. Today, we're stepping into the final and, honestly, probably the most crucial phase of our masterclass on Chapter 4. Right off the bat, I want us to completely shatter a very common illusion in software engineering, which is the idea that software requirements are ever truly finished. If you think you can just write up a requirements document, get it signed off, and then literally never look at it again, you are setting yourself up for a very stressful career. In the real world, as you'll see today, requirements are a living, breathing entity. So let's dive right in and look at how we actually manage all this change. Here is our agenda for today. 1. The inevitability of change. 2. Requirements management planning. 3. Change management process. 4. The emergency change trap. 5. Chapter 4 key points. And 6. Exam focus and conclusion. Let's get started. Section 1. The inevitability of change. The simple truth is, for large software systems, requirements are always going to evolve. There's just no escaping it. To understand why this happens, we first need to define a really fascinating concept from the textbook called wicked problems. Now, a wicked problem isn't evil. It's just a problem that is so incredibly complex and involves so many different related entities and stakeholders that there is simply no way to completely define it up front. Because the core problem itself can't be fully defined, your software requirements are bound to be incomplete from day one. During the actual development process, the stakeholders' understanding of what they need is constantly shifting and deepening. So, why exactly do these requirements change after a system is already being built or installed? Well, think about it. The business environment is highly dynamic. You might have some brand new hardware introduced that your system suddenly needs to interface with. Or the government might introduce new legislation and regulations that mandate compliance, forcing a massive system update out of nowhere. Plus, large systems have incredibly diverse stakeholders. You've got managers, end users, regulators, and as their priorities inevitably change over time, they're going to demand new features or modifications to the system. This diagram brilliantly illustrates that exact cycle we just discussed. We start down there at the bottom left with our initial understanding of the problem, which naturally leads us to draft our initial requirements. But as time passes and we move along that top axis, we develop a changed understanding of the problem. People learn more about what they actually need once they see the project taking shape. This inevitable shift directly feeds into the creation of changed requirements. It's a continuous, never-ending loop. Section 2, Requirements Management Planning. Since we know this loop of change is definitely going to happen, we can't just sit back and let it overwhelm us, right? We have to establish a proactive strategy. During the planning stage, long before the coding even starts, we must establish 4 key planning elements to manage these evolving requirements. First is requirements identification. Second is a formal change management process. Third is traceability policies. And fourth is tool support. Let's break down the most critical ones. First up, let's talk about identification and traceability. Every single requirement must be given a unique ID so it can be easily cross-referenced. And this directly ties into your traceability policies. Traceability means we actively define and track the relationships between individual requirements and between those requirements and the actual system design. Why is this so crucial? Well, so that when a stakeholder asks to change a single requirement, we can trace its unique ID and immediately see how that one little change is going to ripple through the entire system design. It's like pulling a thread on a sweater. You need to know what else is going to unravel. Now, to do all of this tracking, we absolutely need tool support. For small systems, you might actually get away with using shared web documents, spreadsheets, or just basic databases. However, for large projects, you are processing a massive amount of highly volatile information. You absolutely require specialized requirements management tools like the DOORS system mentioned in the text. You need these specialized databases to store data securely, manage change requests automatically, and accurately analyze all those complex traceability links. Section 3, Change Management Process. Okay, so we've planned for change, we've got our unique IDs, and we have our specialized tools all set up. Let's look at how we actually execute a change when a request comes in. The diagram here shows the pipeline of an identified problem moving through 3 distinct stages until it finally emerges as revised requirements. This formal framework ensures that we don't just blindly accept every change request that comes across our desk. We have to assess if the benefits of a new requirement actually justify the cost of implementing it. Let's walk through exactly how that 3-stage process works, step by step. Stage 1 is problem analysis and change specification. We take the identified problem and we analyze it to check if the proposal is actually valid. Honestly, sometimes it's just a user's misunderstanding of the current system. Stage 2 is change analysis and costing. This is where your traceability tools really shine. We look at how the change ripples through the entire system, we estimate the cost of modifying the documents, the design, and the code, and then we decide whether or not to proceed. Finally, stage 3 is change implementation. If it's approved, we officially modify the requirements document, update the system design, and then, finally, change the code itself. Section 4. The emergency change trap. Now that you understand the proper, formal way to handle change, I have to warn you about a stark, real-world pitfall that has doomed so many software engineering projects. This is the emergency change trap. In the real world, a critical bug might pop up and there is immense pressure from management to fix the code immediately. The temptation is to rush an emergency fix directly into the code, promising yourself you'll go back and update the requirements document later. But let me tell you, later rarely happens. Additional fixes start piling up, and suddenly, your code and your requirements document fall hopelessly out of sync. Your documentation becomes completely useless, which makes future maintenance a total nightmare. So always update your requirements document to reflect revised changes as soon as possible. Section 5, Chapter 4, Key Points. All right, take a breath. We've covered a lot of ground today on managing change, but before we wrap up this explainer, I want to quickly zoom out and consolidate the entirety of Chapter 4 to really firmly anchor your knowledge. Let's recap the very beginning of the chapter. Remember this fundamental distinction? Functional requirements describe what the system should actually do, meaning the specific services or computations it must provide. Non-functional requirements, on the other hand, are the constraints placed on the system as a whole. These are your critical emergent properties like performance speed, reliability, and security regulations. Next, we explored how to actually discover and write down these needs. Requirements elicitation is an iterative process, often modeled as a spiral, where we discover needs through interviews and, crucially, ethnography, which really helps us understand the social and organizational environment. Then comes specification, where we formally document these findings into the SRS document. We do this using natural language, structured forms, or visual use cases so that both the users and the developers can clearly understand them. Finally, we covered validation and management. Validation is where we rigorously check the requirements for validity, consistency, and completeness, often using formal reviews and prototyping to catch errors early. And management, as we so exhaustively cover today, is the vital process of controlling all those inevitable changes driven by shifting business, organizational, and technical environments. Section 6, Exam Focus and Conclusion. Okay, students, grab your highlighters. I am speaking directly to you now as we transition into a highly focused exam prep sequence. Pay very close attention to these next two concepts. You absolutely must be able to define traceability. I want you to remember this definition word for word. Traceability is the tracking of relationships between requirements, their sources, and the system design to analyze the impact of proposed changes. Note the spelling there for analyze, A-N-A-L-Y-S-E. If you were asked why we need tools like DOORS, the answer is to manage complex traceability. Secondly, you must be able to list the 3 stages of the requirements change management process, and you have to list them in this exact order to pass your test. Number 1, problem analysis and change specification. Number 2, change analysis and costing. Number 3, change implementation. Definitely memorize that sequence. And with that, a massive congratulations. You have officially mastered Chapter 4 and the incredibly complex world of requirements engineering. You now know exactly how to gather what a system must do, how to write it down, and how to manage the inevitable changes. But that leaves us with a pretty provocative question. Now that we have this massive list of evolving requirements, how do we actually draw the technical blueprint to build them? Well, that is exactly what we are going to uncover in our next topic, system modeling. Thank you so much for joining me in this explainer, and I'll see you in the next one.